So here we're going to look at some linear inequalities. I've got these three examples. I've got 4x plus 7 is greater than x plus 14. So that's a strict inequality. We're not allowing the equals values. 15 minus 5x is less than or equal to. So this is not a strict inequality. We've got the equals part as well included of 19. And then this one here, we've got x on both sides in brackets. 4 times 3 minus x is greater than or equal to 7 minus 3 times x plus 1. And we want to find out what's our range of values of x. So I'm going to put them into set notation at the end. So let's start with this one first. So what we can do is try and get x on its on one side and get this value here, this constant, over to the other side. Now you can treat this part like you would in the equals, if it was just equals there, like it's an equation. So let's subtract x from both sides. So minus the x. So what we can do here, take that over there, we end up with 3x plus 7 is greater than 14. And then we can do the same with this constant. We can subtract 7 and get it over to this side. So minus 7 is what I'm going to do here. So now I've got 3x is greater than 14 minus 7, which is just 7. And now I can get x on its own by dividing by 3, just like I would in an equation. So now I'm going to divide by 3. So then I've got x on its own. So I've got x is greater than, divide by 3, 7 over 3. And then in set notation, my values for x, what I'm going to write is curly brackets, we're talking about x is greater than 7 over 3. Okay, now let's just plug some values in and just check it. So what happens when x is 2? So if x is 2, we've got 4 times 2 is 8, plus 7 is 15. So x equals 2. I've got 15 is greater than 2 plus 14 is 16. And we can see straight away that's a false statement. So therefore when x equals 2, we know this statement is valid. So that works for us. And then what happens when x equals 3? Plug 3 into there, 4 3s are 12, plus 7 is 19. Is it greater than, x is 3 there, so that's 17. 19 greater than 17. That is also working for us with this thing there. So that works. So that's a false one, and that's a correct one. So that's all good. So they all work for both of us in these values. So let's have a look at this one. So now I want to get this 15 away from the x's. So I subtract 15 from both sides. So let's minus 15. So now I've got minus 5x less than or equal to 19 minus 15, which gives me 4. Then I'll want to get this minus 5 out of the way. So let's divide both sides by minus 5. So if we do that, this will just become x, and divide this by minus 5, I'll get minus 4 over 5. But here comes an inequality rule here. When we divide by or multiply a minus value, we have to change the sign of the inequality. So now we've got to put the sign this way. So now x is greater than minus 4 over 5. So in set notation, our result is x, that's what we're talking about, is greater than minus 4 over 5. Okay, now let's plug in some values and see what happens. So something that's going to be less than minus 4 over 5, let's try minus 1. So if x equals minus 1, 15 minus 5 times minus 1, so that's 15 plus 5 is 20. So 20 is less than or equal to 19. That's not a true statement, but that works for our range of values. So that's all good. Now what about when x is 0? Because that falls into our set that we're looking for. If x equals 0, 15 minus 0 is 15, and that is less than or equal to 19. And that works, and it also works in the set notation for us. Okay, let's move on to this one. So first of all, just like you would an equation, let's get rid of those brackets. So 4 3s are 12, minus 4x is greater than or equal to 7 minus 3x, and then minus 3 times plus 1 is minus 3. So that takes care of that. Now what am I going to do? Well, as I did in this in here, I need to bring this one over this side, this 3x. So add 3x. So add 3x. So now I've got 12 minus 4x plus 3x is just x, so minus x. And then I've got 7. 3x has gone over this side and minus 3. Okay, right. Let's get this 12 over to this side and simplify this. So now I need to subtract 12. So subtract 12 from there, I'm left with minus x greater than or equal to 7 minus 3 is 4. 4 minus 12 gives me minus 8. Okay, so now what am I going to do? Well, this time I need to multiply by minus 1 to get rid of this minus sign. So times that by minus 1, I end up with x. Times that by minus 1, I'm left with 8. And as we did here, when we multiplied or divide by a minus number, we changed this direction of the inequality. So then that becomes x is less than or equal to 8. So our set notation will be x is less than or equal to 8. And that's how we write it in our set notation. So let's try some values. Let's try if x equals 7. So that should work for x is less than or equal to 8. So let's try 7. 4 times 3 minus 7. 3 minus 7 is minus 4. So that gives us minus 16. So let's just write that down there. And then when x is 7 in there, we've got 8. 3 8s are 24. 7 minus 24 is minus 17. So is minus 16 greater than or equal to minus 17? So we can see there minus 16 is greater than or equal to minus 17. So that fits for our set notation. So that's a valid statement and it works for our set notation. What about when x equals 9? Let's try that one. So x equals 9. 3 minus 9 is minus 6. Times 4 is minus 24. And then is that going to be greater than or equal to? Plug 9 into there, we get 10. Times 3 is 30. 7 minus 30 is minus 23. Is minus 24 greater than or equal to minus 23? No, it's not, but that works for our set notation there. So there's 3 examples of linear inequalities and the rules we have to follow